Welcome guys for coming to our last Q&A sessions. Before we start, I want to set up some quick ground rules, and then afterwards we can get going. First, I want to introduce the panelists. There's Richard Kiss and Adam Kelly and myself, Richard. I'm also known as Efficient. If you have any questions, feel free to use the Q&A button to ask questions. If after this Q&A session you have any follow-up questions you want, please refer to get us on Keybase and find us on the Chialisp channel and ask your questions there, and we'd be more than happy to answer your questions there. So before we start officially, I'm going to let each of the panelists introduce themselves. I'm going to stop screen sharing now so they can kind of see their lovely faces. And if I would say, Richard, can you introduce yourself briefly, and then we'll go from there.
I sure can. My name's Richard Kiss. I've been at Chia for a long time. And I've primarily worked on CLVM, developing and researching what the Chia's contract language was going to be, and eventually became CLVM. CLVM stands for Chialisp virtual machine or contract language virtual machine, depending on whether you want to use the trademarked version or the generic version. I've done a lot of stuff besides that, but CLVM has been my primary focus.
Cool. How about you, Adam?
Yeah, so I've been at Chia for just under a year, and in that time I've gotten to work with Richard on the CLVM, which is really fun. Done a bit of work on that, and I've also gotten to work a little bit on the block compression we did and on the pooling feature so far.
Cool. Well, that's cool. Thank you for the quick introduction. I think since we don't have any questions yet, why don't we start with a different type of question to just kind of get people to know you a bit. Tell me your story of how you joined Chia and why you joined Chia Network. Adam, why don't you start?
Okay, yeah. Gosh, well, before this, I was working at another cryptocurrency company, actually, and that project was good, but I wasn't. I was working on some pretty standard sort of problems, not learning as much about cryptocurrency as I was hoping from the position. And a friend told me about what was going on over here. I had actually worked with Bram before, so I was aware of the Chia existing, but I hadn't checked up on it in a while. And Gene gave me the rundown, and then I absorbed that, and then I got to talk to some of the technical folks here, Richard and Bill and a few other people, and I was like, okay, that was enough for me at that point. I knew that a lot of really good technical decisions were being made, and that there was a lot of fun to be had. So I didn't hesitate after those discussions.
Awesome. Richard, you're quite the OG Chia Network employee. You want to tell your journey to join Chia?
Yeah, prior to Chia even existing, I think around 2015, maybe 2016, Bram was going to the Bitcoin meetups in San Francisco that I would sometimes attend, and he presented at least one time about his idea of proof of space, and I didn't quite understand all of it, but I think at the time I realized that this would be potentially a much better way to achieve the decentralization goals of Bitcoin. So I started tracking Bram more closely, and then I think I saw an announcement on Facebook or somewhere where he announced that he had started Chia with a guy named Ryan at the time. And so I quickly sent him a message and said, let me know how I can help you with this, because I've been tracking cryptocurrency for a long time. I have a Bitcoin open source library in Python called PyCoin. And one thing led to another, and I accidentally got a job out of it. But I'm pretty sure I was the first employee. And I'm definitely the longest employee that's been around. I think Bram is the only one left who's been here longer than me.
Did you,
So yeah,
Richard,
it was very
did
deliberate.
you give a presentation of your Bitcoin project at a Python meetup?
Yeah, this was back when the meetups were on Mission, 20th and Mission. That one's on
Yes.
YouTube if you want to look it up. It's probably from 2013 or 2014. It's very old.
Okay. Okay, cool.
Did you see him, Adam? I'm just curious now. Or did you think you
Yeah,
saw
were you
him?
there?
I
There
think
were a
I
lot of
was,
people there.
I think I was at, I think I was at that talk, yeah.
Richard probably looked a little
Uh,
different then, at least based on his pictures.
October 5th, 2014. That's
Okay,
what I'm coming up with.
well, I refuse to acknowledge that it was that long ago, but otherwise, yes, I think I may have been in the audience.
That's neat.
What a small world. So
Yeah.
so cool. I guess for me, I'm the newest, one of the newer people. I got involved with Chia about a year ago, but not officially with the company. I was looking for tech to solve a particular problem I was trying to solve. I was building a GameFi project, and Chia fit my specific requirements. And as I got involved, I'm like, wow, I need a lot of things ready, but they're not ready yet. So maybe I'll just help them with some of their stuff while, I kind of wait. So I started doing some simple PRs, and then I started engaging with the community to help with different parts of like community management. And then one thing led another, and Gene said, hey, you interested in working with us? I'm like, well, I'm kind of on my own thing, if I'm happy to talk. And then when we chatted, I basically said, well, I still want to work on my project. He's like, oh, no problem, you could do that on your spare time. So I sort of like, okay. So, I kind of got a job where I can work on Chia, and then also, on my spare time, work on a side project that's on top of Chia. So, win-win for everybody, I think. So that's kind of how I got into Chia. So
Chia 24/7.
yeah, I think Gina's done a really great job recruiting some of the folks from the community to help, fill a lot of positions that we really needed once they got, I guess, the last round of funding where they could actually ramp up, because we're kind of going to that scaling mode now, right? Where you need a lot of other people besides just the engineers, right? So that's been really helpful, where he could pull from his networking as well as the community. So that's been good. So let's talk a little bit more about Chialisp. I don't know, I'm not sure if anybody has watched the other videos. If they have, maybe this is the same kind of question. I'll try to change it up a bit in subsequent questions, but tell me a little bit about how, the story behind when you first talked to Bram and how CLVM came to be, Richard, because I find that such a good story, even though, you probably told it a few times. Probably you might add some new flavor that we didn't hear from the last time.
Yeah, so PyCoin has an implementation of the Bitcoin scripting language. It's very complete. I got a lot of contributions which helped me debug it, and because I got so close, I got so many details of the implementation I had to learn about. I realized just what a mess it is and all the things that were wrong with it. So the original plan, I remember going to WeWork and Ryan and Bram, one of Ryan or Bram telling me that the plan was to start with the Bitcoin C++ source code and just morph it enough so that it would use proof of space and time. And I thought, oh, this is not going to work. So then Bram knew roughly how the Bitcoin VM worked, but he didn't know all the details. So I was really relishing the idea of exposing the dirty details of Bitcoin script to him, so that we would have to come up with a new plan. And I've always liked Python, and I know Bram liked Python, so I thought maybe we could just write something from scratch in Python instead of trying to take the Bitcoin code, which it's much better than it used to be, but just the way it was originally architected has made some things very difficult to clean up, especially when refactoring is especially difficult for cryptocurrency projects, because you need consensus to remain precisely identical to all prior versions. And so refactoring consensus is just fraught with it's a minefield, essentially. So, there are really limits on how much they can change. Yeah, so just seeing the look of horror on Bram's face as I explained some of the hacky things that you have to do in Bitcoin script was enough proof for anyone that he's not Satoshi.
Yeah, I imagine it didn't take you long to convince him that the Bitcoin VM was not the way to go.
Yeah.
So you went on the journey of proposing CLVM. How? Like what got you to where we are now?
Well, in the past, several times in the past, I've worked with people developing their own languages, and I've always thought that Lisp is one of the best ones to develop, especially if it's primarily targeted towards just computers parsing and running, because parsing Lisp is very easy compared to parsing other languages. I've been involved with, I worked for this medical device company, and the medical device had a language, needed a language to run a script to display messages to the user. And I thought we should just do this in Lisp, but the guys who ended up implementing it, they came up with a basic language, which meant that they needed a compiler. They were really stoked on learning Lex and Yak. So no, they didn't do a compiler. They did an interpreter, and it ended up being 32K, which doesn't sound like much, but this thing only had 64K of ROM. So that wasn't going to work. So what I did was I took their Lex and their Yak, and I turned their interpreter, which would just run the code as it parsed it, into a compiler, which would then sort of a very basic compiler, which would just create a binary version of the code. It was mostly just text and printing text on the screen. And then I wrote a VM that would take this binary code and run it. And the VM ended up only being about 5K of code. So I recovered, 27K of the ROM that we could then use for other things, which was kind of necessary because we ended up filling that ROM.
Oh, yeah, that's cool.
It always annoyed me that we didn't just use Lisp.
So that's how you propose a Lisp-based language for Bram to consider. How much did you have to prove to him or convince him that this is the right way to go?
Not too much. I mean, he's mostly worried about the capabilities of the language. Well, I shouldn't say capabilities, because when he says capabilities, he always means something very specific, which is different from what I mean. He's worried about making sure that there are no side effects, essentially, but also being able to pass information from one chunk of code to another. And CLVM really is sort of the minimum thing that does all that, except for paths. Paths is this thing where you can pass in an integer and it traverses an environment tree quickly. That's the one hat tip, the one concession we made to it's a extra feature that wasn't strictly necessary, but it lets you write programs that are much more compact.
Yeah.
But besides that, CLVM really is just sort of like, this is what we need, and this is the least thing that you can create that can do it. Well, I mean, I guess that's not exactly true. There's this thing called, Adam, do you remember what the thing Russell's language is called?
Oh yeah.
It
Simplicity.
starts with simplicity, yeah.
Yeah.
So CLVM is like simplicity with jets, I like to say.
Yeah. Yeah. I mean, Russell really emphasized having the minimal thing, of course, because he wanted to have it provable. We haven't engaged in any formal proofs yet, but of course the CLVM is very small, which helps us have confidence and write more tests. And that's one of the things when I started that I was very impressed with. That there, if you look at the CLVM implementation, it's very compact and there's not a lot of extraneous code. So that and that couldn't have been done, without the decisions that Richard and Bram made. Yeah, it's pretty nice.
Cool. So, one of the things that you kind of touched on, there's 2 points. So I'd love to kind of ask both of you your perspective. One is, there's tech debt, right? Everybody talks about this. Over time, your technical solution accrues debt and you want to kind of refactor. You mentioned, Richard, that it's really, really difficult to refactor in blockchains for a variety of reasons, right? So how did you kind of make sure that Chia, Chialisp, CLVM wouldn't have too much tech debt that would cause a potential fork, right? Which is the other rule that I hear a lot. Bram says is like, we will not fork, right? So like, how did you guys approach that, making sure that those two things can actually, happen? Very low tech debt, I'm assuming, because you can't have a lot, otherwise you would have to fork at some point. So how did you see that?
Well, the core to CLVM is this function called run program. And so just making that run program function as simple as possible, where there's a tight loop where it pulls in the next operator and executes that operator. And all the operators are homogeneous. They all work the same way. They just look into a function table and call a function, except for there are 3 magic operators, I guess, basically. There's the one which traverses the tree. There's the quote operator, which essentially stops evaluation and just returns a literal value. And the apply operator, which essentially changes the environment that the program, basically the arguments that the argument environment that the program is running in, and runs a new program with this new environment. So those 3 are a little bit magic, but everything else, like plus and multiplication and F and R and L and X, they all otherwise work the same. So a lot of the code is nicely orthogonal, and those special cases you can analyze very carefully. And then for future expandability, there's an operator called soft fork, whose the goal is to hide future soft forks, and all code that only works after soft forks gets hidden under this soft fork operator. So legacy clients will, legacy peers, when they see soft fork but don't know what the program under the soft fork means, just return nil. And even after the soft fork, it will still return nil, but it can also do some extra stuff in there that could cause the contract to fail. And so what a soft fork is tightening restrictions, essentially, so that transactions which worked in legacy clients fail in post soft fork clients.
Okay, gotcha. And
Yeah.
can you have more than one soft fork, or is like you have one soft
Yeah.
fork? Okay, it's going to
Yeah,
be
the idea
nested.
is soft fork will take multiple parameters, and one of them will be, we're on soft fork version number 2.
Okay, got it. That's cool. So Adam, any thoughts or additions to the topic of tech debt or no forking
Yeah,
policy?
yeah, definitely. So one of the implications of what Richard was saying is that the operator implementations. So there's this concept in functional programming of referential transparency. Basically, it means you don't have to consider effects outside of your function to understand what's going on. So the operator implementations in CLVM's run program, even if you're programming a functional language, you have a lot of choices to make in how to implement the sort of built-ins. But the way that they're done in this implementation is that there's a very uniform interface where the arguments are passed in all in the same way. So those operator implementations are very tiny, which is also important when you're trying to reason through and eliminate bugs. So all of that code that manipulates you could think of it as the argument stack is lifted out, and that only occurs once. So that helps that to be small. Another thing I want to point out is something that Bram and Richard sort of emphasized, and that sometimes I was like, maybe on the other side of wanting, but I definitely see the benefits, which is implementing certain parts of the system in CLVM itself. I'll take an example. There's a function called SHA-256 and if you know about how objects are represented in the CLVM, you can think of them as a tree of data. And this is just a fancy way to get a deterministic hash out of a tree represented this way. Now we had it implemented in, the interpreter itself. And I was like, well, let's just keep it in there because it's fast. But Bram and Richard are like, no, let's implement it in here. And the reason in there is if somebody else, including ourselves, implements a new CLVM, we want it to operate the exact same way. And the more of it that's implemented in CLVM and not in, say, Go or C++ or whatever you're writing your version in, the more likely it's going to stay exactly the same. So you're kind of lifting that debugging out of your implementation of that operator and out into the CLVM implementation, which is pretty small. So I think that is very much in service to reducing tech debt and basically stamping out bugs early.
Okay, so if I were to summarize, because you kept it to such a small set of operators and what can be done, and you have very, very specific ways of passing in parameters into the smart coins, you ultimately, unless you had not thoroughly tested those basic operators, you're really, all your tech debt is on the CLVM layer or the Chialisp layer, which is whatever you wrote on top of that. For instance, a singleton, if you want to upgrade later, you can upgrade that, but then the older singletons will still work on the chain. But at the same time, you can have a newer version of singleton for the newer smart coins. Is that kind of a good analogy or not quite?
You're putting in new things as well, but definitely the right flavor of what we're getting at. Yeah.
Okay, gotcha. Okay, cool.
Yeah, well, yeah, one thing to point out is CLVM knows very little about the Chia blockchain.
That's true.
I mean,
okay, understood.
It's just a generic programming language that Chia blockchain runs and then takes the output and interprets it in a particular way.
Okay,
Yeah,
And
and the conditions language is kind of an innovation too, actually, the output of the CLVM program. It takes like what Bitcoin does and sort of turns it on its head. Like a Bitcoin script, it runs and it checks things like signatures, and it can fail if some condition isn't met. And then at the end, it returns a value 0 or 1, basically saying this transaction is valid. And what Chia does is what CLVM does. Well, I guess Chia is the thing doing it. Is it runs a CLVM program, and the output is a list of conditions that now Chia blockchain has to check that are true.
Yeah.
So the CLVM doesn't need to know anything about like coins or coin values.
understood.
Although your program can know about it.
Right.
Your CLVM program can know about it.
You had something to add, Adam?
No, I was just gonna say that I really like that it's designed that way, because not only is it's much more modular, because there's kind of your CLVM program runs. There's some inputs, there's some outputs, and that's the interface to it. But with a Bitcoin script thing, like Richard was saying, you know, when it runs that operator, it's also doing checks that kind of are reaching into.
Yeah, it's a layer violation almost.
Exactly, yeah. Yeah, and so it's much easier to make security bugs with that type of organization of the code. And of course, in Bitcoin being written in C++, that's even more scary. So not that
So
those
PyCoin,
guys can't write.
PyCoin has the feature where it can solve a standard Bitcoin transaction. So, you know, if you have your private key or whatever. And the way it works in Bitcoin is it's a stack-based machine. So you're what we call a solution in Chia. You create a solution in Bitcoin. And for the standard transaction, it includes a reveal of the public key, and then the signature or something like that. And so in PyCoin, I did this thing where I would run the Bitcoin script, but without any parameters pushed, without any solution parameters pushed onto the stack. And it would go through, and when a condition was checked in the Bitcoin script, like check signature, it would make a note to itself saying, okay, for this to work, this value has to be equal to a signature of this other thing. And so I would run the Bitcoin VM under this model. And when it finished, it would have a list of basically what are CLVM conditions. And then I could go back and say, okay, so the first thing that I have to push on the stack is the reveal. And the second thing I have to push on the stack is the signature. And I got it working that way. And then I thought, well, what happens if I tweak the standard transaction so that instead of the reveal and the signature, it wants the signature and the reveal. So I put what's that thing? What's the operator which flips the top? I think it's called swap or something.
Swap, I think.
Yeah, so I took a standard Bitcoin transaction, added a swap in there, gave it to PyCoin, and it still solved it. And so I think this might have sort of been the genesis of the conditions language, because internally, when I ran this Bitcoin script, it returned like a list of the conditions, namely like the first thing has got to be a reveal, the second thing has got to be a signature. And I made actually quite a lot of progress on this, but it doesn't handle ifs yet. With ifs is really tough because then you have exponential blow up with your cases. But it handles multi-sig that way too, because you have to put a bunch of, you could potentially, in Bitcoin, if you have a multi-sig, you could potentially have to require multiple signatures. So Well, I think I got that working. I think it works in Pycoin. It's been a while since I looked at it.
Cool. So we have a couple questions that I want to get through.
Oh, okay.
So as dApps get developed on or adjacent to Chia blockchain, it seems like new standards will be defined. What's the company doing to shepherd those efforts? Do either you want to take a crack at it? If not, I can do it too. So who would like to try?
Adam, go ahead.
You know, I think both of you guys have had a lot more exposure to dApps. Richard, Seattle Richard, why don't you take this one?
Sure. So we are discussing right now getting a standard effort like a BIP or EIP going, which is actually, believe it or not, where we're at right now is trying to figure out what's the acronym we're going to use first. You know, and once we get that going, we will want to start help shepherding some of these efforts. We are still very early. Which kind of goes into the next question you have. There are standards that we are developing ourselves right now, but we're doing it through code, right? We're going to try to show some of the basic kind of things that we would like to see as templates, and we want to see people improve upon it. So Richard or Adam can talk more about like the 3 or 4, I'll say, you know, template type things we're trying to do in Chialisp right now that we want to roll out for everybody. So again, to reduce duplicate effort.
Well, there's ERC20 type of things, which we're calling, the name is colored coins that we're using internally. We don't have an external name yet. And then there's singleton, which is probably sort of, you could think of it as analogous to an Ethereum contract, except for in Chia, the programs live in a coin. So a singleton is just a coin that contains a contract that can't live anywhere else. It proves that this is the only coin that it lives in. And so when this coin is spent, it creates a single new coin that also has the same contract. It might possibly create other coins, but they have different puzzles in them. And so this is how the contract continues to live. It's like a parent that always has one child and then the parent dies. Well, that sounds sad, but
but the user is killing it, so it's okay. It's oh man,
that's true,
yeah. That didn't sound good either. And then there's a couple others. DID, right?
Oh yeah, that's distributed identity.
Yeah. Yeah. So so Chia actually has several really cool examples of smart coins, but some of those were written before the singleton wrapper idea had finished being I don't want to say designed, but you know, finished being iterated on. So I believe our goal is to take those prototypes that we wrote before and move them over to use singletons, because what that lets us do is move a lot of that code that implements the assurances that there's only one copy of this thing and sort of makes passing data from one of them to the other nicer, for us to standardize on that. And those will be better examples that way. But yeah, Richard, does the singleton framework give us any other advantages besides the oneness of the contract, the non-duplicatability on the chain?
I think that's its primary feature. And by having a standard for it, that means that when people come up with something that works with a singleton, it can work with the whole family of singletons. So anything that conforms to the particular singleton contract. So DID, I do want to say something about that. DID is this really cool idea. So Facebook has this thing where you can nominate a set of like 5 friends to act as validators for you. So if you ever forget your password, you could just go to these 5 friends and maybe like, I don't know the exact numbers. Let's just say it's 5, and you can, any 3 of them, let's say, can say, yeah, this guy lost his password, and those 3 people can can reset your password. So it's great for Facebook because that's less work for them. And like I guess that works even if you lose access to your email, you know. So
Right.
and so DID is essentially a version of that where you have a singleton. The singleton represents you, well, me, and I can nominate friends who also have singletons, nominate their singletons to act as validators. Maybe validators isn't the right word, but testifiers or whatever. So if I ever
Yeah.
lose the private key to my singleton, then I can just get you to sign a message, you, Richard, to sign a message, and you, Adam, to sign a message, present it to the blockchain, and I can recover my singleton.
Mm. So it's like an M of N contract, but also it can.
It's password recovery.
Yeah.
No blockchain has password recovery that I'm aware of.
Mhm.
Oh man, that's
Yeah.
yeah. There's yeah. It's like a bit more advanced implementation of something like a green wallet, where there's another entity out there who can maybe, you know, recover your wallet after a certain set time or something like that.
So as a follow-up, they're asking, is the singleton effectively a mechanism for maintaining custody over a private key to do the things one can do with the private key? What else can it do besides that?
Well, because so okay, that's a good question. So because the thing that you're recovering is not just a private key, but a singleton, or and that singleton is of course a coin on the blockchain that is attached to this program. That program can also have other rules. So you may have many singletons that have different programs attached to them. You know, you may have one that lets you interface with your bank, and a different one that is sort of like your charity singleton. But it's not just it's sort of one step removed from just a key. It's also like what the code attached to that coin can do, that's being recovered. So for different singletons, you might want to have different groups of friends or colleagues, you know, like you may trust your zoologist friends to recover this one, but not that one. Sorry, I don't
Well,
have.
you're talking about DID, right?
Yeah,
Yeah,
so it's not
DID.
just DID, so just generally singleton. So why don't you use the pool NFT as a good example of adding functionality to a singleton? And maybe that'll help elaborate a better answer for.
Well, the singleton contract is just a shell around an inside contract. And the singleton shell, all it does is enforce that you can only ever create one additional coin that has the, well, a singleton has a name.
Right.
Well, singleton has a name, and the name propagates for forever through all the children and grandchildren, all the descendants. And the singleton shell ensures that only children of this singleton can have that singleton name. That's really all the singleton shell does.
Yeah, and you can verify it by walking backwards on the blockchain. Sorry, I was going off on a DID tangent.
No problem. So cool. Back to the DID tangent, somebody was asking, I don't know if either of you know, and I don't know myself, how compare and contrast Chia DID against BrightID. Do either of you know BrightID?
I do not know.
No, it sounds familiar, like I've heard of it, but
I'll do a Google search while you do the next question.
Sorry, the crypto world's so big. Not everybody knows everything. But we'll look into it briefly to give you an answer, hopefully.
It says BrightID is a social identity network that allows you to prove that you're only using one account. It's the holy grail of digital identity. I don't know. I'd love to see how this works because this is a really hard problem that governments haven't been able to solve. I mean, if someone gets 2 social security numbers, how do you prevent them from getting welfare twice?
Yeah. Yeah, I'd be interested to look into that more.
So, but the answer is no, it's not quite different. It's not quite the same thing because anyone can create as many singletons as they want. So we're singletons and DIDs is not trying to solve the problem of symbols.
And just to be very clear, it could be a product that somebody focuses on with Chialisp and our blockchain to implement a BrightID like solution. But our goal is more to provide the infrastructure to create such products and not specifically a particular product line. So you can look at it as us providing more of the tools to create such solutions potentially.
Yeah, a Chia singleton is an ID, but not necessarily your ID. So
Correct. Okay, cool. So the follow-up is, so singletons could definitely act as building blocks towards creating information hygiene immune response. Immutable as response? I'm not sure what immune response means.
yeah,
I don't quite understand the question.
Yeah, need a slight rephrase.
Yeah, but in general, we're giving the building blocks for you to build these type of solutions like BrightID. I would say if you can find how to solve the real world problems associated with it from a pure blockchain implementation of making sure the ID is specific to a particular user, we could definitely do. But there's a lot of business logic that needs to be solved that we don't deal with that. You know, we're expecting the development ecosystem, you know, to develop such things, and we provide that baseline technology to help ensure that can happen. So while we get other questions, I like to ask you guys a little bit about how do you see in the future people will learn how to make Chia very auditable, right? We keep on saying it's very, very secure. It's very easy to audit, but it's a different mindset of how to do that. How do you picture how the ecosystem will grow so that we can, you know, scale that, right?
So you're talking auditing CLVM contracts?
Exactly, making sure that there aren't any exploits, you know, flash loans from God type things.
Right. Well, proving a program is correct is challenging, but it is doable. The more complex the language becomes, the harder it becomes. So that's another advantage of keeping CLVM simple. I don't have a lot of experience with proving correctness, but I do believe that it is possible. I mean, one hard thing to do is to define correctness in, I'm just talking out my butt here, but I think one thing that's probably hard to do is define correctness in a way that's rigorous enough that you can even begin to start proving.
Yeah.
So that's a challenge, especially in something so complicated as a cryptocurrency system. But like one thing you might want to try and prove is that our singleton shell, a singleton with a particular name, you can never create a second coin that has that looks like a singleton of the same name that can also be spent, because it's trivial to create one that has the same name, that has the same puzzle hash, but then you can't, because it's counterfeit, it can't be spent, which means it's kind of just like a dead end. It's like dust that can never be undusted.
Yeah, the singleton is a great target for formal verification. So what you usually do with these tools is you write a proof for a very, very small part of your program, and then you build it up recursively, just like a math proof. So Chialisp lends itself to that because you can isolate parts of the system.
Sure.
Like, for example, if we're trying to prove cons, or if we're trying to prove, something more complicated like addition, we only have to deal with addition and the code that implements addition. So still hard, but if we could farm out those proofs to different programmers, come together, say, okay, we've proved all the operators. Now we can start to prove singleton. So it's a much more approachable problem than like looking at the whole Bitcoin code base and going.
Yeah,
oh,
you could think of
man.
subroutines like defs as lemmas to your final proof almost.
Yeah.
Build it up that way.
Yeah. So from formal verification point of view of auditability, I feel like we're in good shape there. I think there are some other aspects to auditing too, though. There's how Chialisp connects to the rest of the system, like the block verifier and the stuff that executes the conditions. So that's more code verification than contract verification, though. So give me a hint on which direction you want us to go in.
Oh, that's okay. I just wanted to give people a flavor of, what they would have to approach in making sure that they audit their code to make sure it is working as intended, right? Because a lot of times the challenges have been for, well, say in Ethereum ecosystem is some people say, well, that smart contract was coded poorly, that's why it got exploited, right? And we are hopefully claiming that we are better at this. Now, there's some intrinsic value of why we're better at it, which is not as complicated of a language, right? So that simplifies a lot of problems in itself, right? We also,
well, I mean, EVM isn't that complicated either.
Okay.
Well, that would be an interesting exercise, actually, is to go through the list of exploits in Ethereum and see how likely it would be to write something in Chialisp that would be similarly exploitable.
Right.
Yeah, that's a good exercise. Yeah, so what you're talking about is more like, I've written a program, can I run it and can it screw me over in a way I didn't expect? That's a bit different than what we've been talking about, although I would hope in the future we could take that higher level of formal verification and build it up enough that we maybe could express some of those business logic things, like, this coin can never escape these set of conditions. As far as I know, no crypto system has that level of formal checking yet.
Okay. So the answer up, Moto, you were asking about, can we do the information hygiene? Does it have building blocks? Yes. If you could think of how it would work, you probably could build it on Chia with Chialisp. I don't understand enough about your product idea to really verify that, but my guess is probably yes. Your next question, I think, is very interesting, so we'll answer that, which is, how easy is it to forget to carry my arguments and lose all my coins to a mean farmer?
It's pretty easy, but you go to the doctor and says, "Doc, it hurts when I do this," and he says, "Well, don't do that."
So, okay, cool. I mean, this actually comes into the whole, auditability, how to audit your code. One thing that I've seen Chia, the company, do really well is every programmer creates their own testing loops to verify automated testing of their code. That's like part of the DNA of building all the code projects that I've seen. And that seems to help a lot in at least preventing recursion. was it not recursion?
Regression.
Regression. Thank you. I need to start with R. Type bugs. And having a lot of eyes on it. One of the reasons why we do like open source is we get the whole community to look at things, and when you cannot imagine some of the things we've gotten, from a community where they fix some really, I would say, intricate bug that we did not realize at the time. So that's definitely something we recommend as best practices if you start doing this stuff. So, any other thoughts?
Yeah, well, you've made me think of something that, so I haven't written as many smart contracts as some other people on the team, but one thing that we don't have yet is sort of a few levels down from the formal stuff we've been talking about, which is, if I'm making a smart contract of this type, I expect to see certain types of conditions come out of the program. So a smart contract on the Chia blockchain may involve multiple coins and multiple programs, but if you're expecting certain things, like say, one of the ways to spend this coin is by signature check, then we could check. This is future tool development and checks for our developer ecosystem. We could check, I need to see an ag sig me in the output conditions. We don't yet have sort of a set of templates for standard things that you may do, but I can guarantee you that when we do have that, those programs will be pretty small and compact. So I could see us being able to check some of the properties. Richard could probably expound on that a bit more, but
thoughts, Richard?
I don't have that much to add at this point.
Okay. Is it possible or likely for a Chainlink or someone else to use Chialisp for an off-chain oracle, a clone chain, for example? Would this have an advantage?
Let me look up.
I don't know what Chainlink is offhand. But I mean, yeah, anything could use CLVM. I would expect off-chain oracles would likely, they might use messages formatted in CLVM, but not necessarily. CLVM, you could use cons boxes, to separate out different data types. Like you might want to say, Apple has price X at time Y, and then you sign that with the BLS 12381 signature, and then it could be validated in CLVM. So anything that also understands CLVM could also validate it. But you wouldn't necessarily need something as complicated as CLVM to check the signature on that. Would just have an advantage.
Okay.
I don't know the answer to that. Maybe if I knew more about Chainlink.
Yeah, it looks like their chain specializes in oracles. So I'm wondering if the main use case is oracle information flowing into their chain or flowing out of their chain.
Sorry, we're not necessarily up on every
Yeah, I'm too
project.
ignorant to comment intelligently on this. I'm looking at the website right now. It looks like connect your smart contract to the outside world. Chainlink's decentralized Oracle network provides reliable, tamper-proof inputs and outputs for complex smart contracts on any blockchain. So it seems like Chainlink is going to be doing the translation more than CLVM. But yeah, so I guess Chainlink more than Chia. So Chainlink could incorporate CLVM and then maybe talk to CLVM to Chia somehow.
Yeah, maybe one use case of that would be sort of a standardized Chainlink format of a CLVM program, so that people wouldn't have to would only have to write that Chainlink bridge once, and they could use it for multiple different oracles. Yeah, sorry, I'm not. Okay. Chainlink is an Ethereum token that powers the Chainlink decentralized Oracle network. Okay, so they're using the EVM here.
Yeah,
Okay.
in particular, I doubt they support BLS 12 through 81, but who knows?
Yeah.
Okay, we're coming up to the hour now. Thank you very much for everybody asking questions. You guys are on the bleeding edge of adopting Chialisp and CLVM, and that's great because you will be probably building some of the first projects that might be very successful on Chia. If you have any further follow-up questions, feel free to come join us on Keybase and go to the Chialisp channel, and you can ask any further questions, and we're more than happy to answer them. And then we will probably have a future AMA on a monthly basis as people starting to learn more about Chialisp. I'm sure we'll get more questions, so we would like to do this on a monthly basis. So we hope that you continue to enjoy learning about Chialisp as much as we have, and hope we can see some great DeFi projects coming from you guys soon. So thank you again for joining us today, and we hope to see you in the Keybase community, and we'll chat later. Have a good evening, guys.
Good night.
Thank you, Richard. Thanks, Adam.
See ya.
Thanks.